What is bioaccumulation? Have you ever wondered how toxins make their way into the fish we eat? This process is known as bioaccumulation. It occurs when living organisms absorb harmful substances faster than they can get rid of them. These substances often come from the environment, including air, water, and soil, or from the food they consume. Bioaccumulation happens because the organism takes in these chemicals quicker than it can break them down or excrete them. Over time, this leads to a buildup of toxins in their bodies. Common examples of these harmful substances include pesticides, heavy metals like mercury, and industrial pollutants such as polychlorinated biphenyls. Organisms can absorb these toxins through breathing, skin contact, or ingestion. From the viewpoint of environmental anthropology, bioaccumulation is important because it impacts not just individual organisms but entire ecosystems and the human communities that depend on them. In marine environments, for instance, tiny organisms like phytoplankton absorb toxins from the seawater. These toxins then move up the food chain, affecting larger creatures like fish and marine mammals. As these toxins move up, their concentration increases, a process known as biomagnification. This means that top predators, including species that humans consume, can accumulate dangerous levels of toxins, which poses risks to food security and health. The depletion of marine resources, driven by climate change and pollution, makes understanding bioaccumulation even more critical. Indigenous and coastal communities that relying on fish and marine mammals for their livelihoods are particularly at risk. The health impacts of bioaccumulated toxins can lead to chronic illnesses and reproductive issues, which can disrupt cultural practices and ways of life tied to marine resources. In essence, bioaccumulation is the gradual buildup of harmful substances in organisms, stemming from their environment or diet. It plays an important role in the health of marine ecosystems and human populations, especially in the context of environmental changes and resource depletion. Understanding this process helps us grasp the broader implications of climate change and pollution on our oceans and communities.